Hey everyone, welcome to Inverse Trig Functions. This is Nicholas JMV. So this is our introduction to inverse trig functions. Okay, so let's look at what we're going to be talking about here. So number one, in order for a function to have an inverse, remember it has to pass the horizontal line test. This only happens when functions only one-to-one functions have inverses. And I want you to pay attention. Right here I've drawn the sine function. If I draw a horizontal line here, that function fails the horizontal line test. So it actually isn't one-to-one. But what mathematicians have decided is if we restrict the domain, we can actually have an inverse trig, and that's what they do. So what they do, here's the inverse sine here. We label this as inverse, okay, sine of x. Okay, and what happens here is, how do we get that graph? Well, think about inverse functions, okay? We're actually just taking this portion. We restrict the domain from here to here, okay? This is where we get our inverse, okay? Because that's one-to-one that passes the test. And the idea here is if we switch x and y, okay, if you look at that graph here, we're kind of seeing this piece right here. Now, we notice that the domain and range will switch. Okay, so the domain of inverse sine here is from -1 to 1, and the range is going to be from -π/2 to π/2. How do we get that? Remember, when we talk about trig functions, we switch x and y. Notice the restriction. The x restriction is from -π/2 to π/2, and that becomes the range of your inverse because we switch the x and y. Look, the max and min, -1 to 1, there's your y value, and then it switches here. Look, from -1, it becomes your x value. Okay, so inverse sine is written like this. It means we're looking for angle measures. There's the domain and range. Okay? Now, when we look at inverse cosine, it's different, okay? Let me fix the papers here. We can't look from π/2 to π/2, right? Because it still fails the horizontal line test. And so what they do here is they go from 0 to pi. So mathematicians agree that if we restrict our function to this, there's the inverse, and you can see that drawing right here matches up with this drawing right here. So this blue part is the restriction. Now, if the domain of the restriction is from 0 to pi, that is the range of inverse tangent, or inverse cosine, I'm sorry. So from 0 to pi is your range. Your domain, okay, okay, is the y value. So we go from -1 to -1. So same thing here, -1 to 1 is your domain. We write inverse cosine like this, cosine inverse of x. Again, when you have inverse cosine, we're looking for angle measures instead of coordinates now, and that goes for all inverse trig. Tangent's our last one, so there's no problems we're working out here. We're just looking at the graph, okay? Now, with this graph, we have to restrict again, and it's fairly simple, and we just are using this portion here from -π/2 to π/2, right there, our first period. See how it matches up here? And notice that the inverse tangent here, the domain, is the range of tangent. The range of tangent was all real numbers. So that means the domain here is all real numbers for my inverse tangent. My range, now the range here is the range of our inverse tangent is the x of our tangent function. Tangent is undefined from -π, well, the period, -π/2 to π/2. And so that's what our range is here. Okay, we go from -π/2 to π/2. And if you look at our inverse tangent graph, okay, this is just going to keep going on and on. So our range is somewhere up here and down here, a little bit past -1 and 1, 1.57, and it's gonna follow that asymptote, just like this graph is gonna follow that asymptote like this forever. So our domain is all real numbers, but our max and our min has to be between -π/2 and π/2 because that's the domain restriction on tan. That becomes the range restriction on our inverse. Okay, so I just wanted to show you the graphs of tangent, inverse, tangent, or inverse sine, inverse cosine, inverse tangent for you. In the next video, I'm actually going to evaluate some of these and show you what to do. But that's how we get these inverse trig functions. We restrict the domains, and we make those functions one-to-one, so we have inverse trig. So if you have any questions or comments about this video, let me know. We'll see you next time.